over the world, biotech startups are cleaning up our toxic way of living by discovering new ways of harnessing the power of nature. But instead of fighting against the status quo, one London company is changing it from within by working alongside local communities to create a more sustainable future. Plastic and pollution choke many parts of our lives. It was sites like these that shocked EHAB Syed into making a decision that could revolutionise industry.
When I started my master's degree at Brunel University, I led a research project investigating the waste streams in the UK. And what I found is that the construction industry were generating incredible amounts of waste. That sort of led us on a really exciting journey that led us to where we are now, of developing new materials for the construction industry.
The production of cement creates so much CO2 that if the industry was a country, only China and the US would emit more in a year. But EHAB believes nature can show us how to create greener building material options. You just have to know where to look.
I think there's some here.
Oh wow, look at those beauties.
Yeah.
Oh, and there's little threads, is that it?
There's the mycelium.
These little fingers of fungus are mycelia, which act like the janitor of the world, cleaning up nature by decomposition and cycling of nutrients. Just sending out these little threads.
Yeah.
And one day you could grow up to be insulation panels. Which is exactly what EHAB and the team at Biohm are doing here at their R&D labs in London. They're growing sustainable, regenerative insulation panels.
When we were looking at the materials that need to be addressed, it was very clear that insulation, sheet materials, and concrete or structural materials were the main three key areas. So when it came to investigating insulation, we wanted to look for examples in nature of structures that are naturally grown and that are naturally created to achieve the highest level of porosity.
When we walk into a field or forest, often the only part of a fungus we can see is the fruiting body, such as a mushroom, which is found above ground. These contain reproductive spores which are shed and carried away by the wind, animals or water. If they land where there is moisture and food, they can germinate and produce hyphae, tubular filaments or threads that are microscopic. These hyphae divide repeatedly along their length, creating long branching chains until they form a network of threads known as mycelium, which is visible to the naked eye. As the mycelium spreads, it releases digestive enzymes, allowing it to break down organic matter such as wood into smaller molecules which feed the fungal network, helping it to grow. At Biohm, they're harnessing that ability.
Mycelium is these little filaments, these little hairs that you see growing here. And then when it gets really, really dense, these network of fibers create something solid, just like you see here.
This is actually mycelium.
Indeed.
But this is in the form of this is what the insulation panel actually looks like.
Yeah, so it's a bit of a smaller version, but this is exactly what the insulation panels look like.
Wow, I've seen pictures of this and I just wanted to touch it. You can hear it's almost like a plasticky, woody, mushroomy kind of texture. It's incredible, isn't it?
So it all starts with something like this. This is called agar, and it's a very nutritious jelly, essentially. We pop a little piece of a mushroom, literally need a microscopic bit, and then they'll happily grow on this sort of medium.
One petri dish can provide the startup medium for 7 panels.
So from this, we can sort of assess different strains, we can see how well they're growing, we can have an idea of how strong they are, and it's a very key first step. This is sort of our data bank of mycelium, if you will.
From the dish to the jar, the mycelia are fed on nutritious biomass and waste products such as grains, which eventually become part of the panel.
And then we pop it inside one of these things. So I can pop some of these open for you, and inside...
Whoa! How many panels is in here?
Not so many, actually.
Hang on. I don't have another look
absolutely.
at this. So one jar, you've just got to put in, lots of feed, and then you put that one jar in here and it creates that mass.
Yeah. Even half a jar is enough for this, even less.
From the petri dish to the panel takes about 6.5 weeks. I'm going to go and get the panel so we can understand this, because that just looked like a big load of sort of fungusy porridge. So how does that sort of, do you put it in like a shape? So you put it into like a dish to make it square or rectangular?
Yeah, there's lots of ways you can go about it.
We can't go into detail because it's all IP protected tech, but basically, as the mycelium grows, it consumes the food waste, filling the gaps, creating a dense mass. The panels are then cured, killing the mycelium, making it ready for market. But will it sell? So what makes this different from other insulation panels?
Well, the main difference is that it's a completely natural product. When it comes to performance, it's outperforming almost everything on the market when it comes to thermal conductivity, health and well-being impact, the fire resistance of the material, and we're able to achieve all these advances just by harnessing nature's genius rather than adding coatings and chemicals to it.
And sound as well.
And sound as well, yeah. So the acoustic properties of mycelium are incredibly advanced. We're currently accrediting our insulation for both acoustic and thermal insulation.
The different species of fungus and what they are fed change the qualities of the panels.
Sustainability is always perceived to be a premium. A material that is natural and good for the planet and good for us is, always attached to a premium label. And we want to show that sustainability can become mainstream and can be the norm.
There's also sheet materials made out of bio waste, such as orange peel, and a skin of mycelia, which is like leather. When do you think you might be able to build a house out of orb and mycelium? I'm kind of interested now.
that's where our plant-based concrete comes in, and that's what we're working on over the next 2 years.
What are you not working on? Maybe we should look at that. To really change the industry, EHAB believed Biohm needed to include a component of social science as well. That was about the time the Onion Collective called. Perched on the west coast of England is the town of Watchet, population less than 4,000, but it includes 5 very determined professional women.
The market doesn't really work here. The state increasingly doesn't have any money here. So if someone else doesn't do something, then the place just kind of quietly gets worse and worse. We have the lowest social mobility in the whole country in this part of West Somerset.
So why choose Biohm, and why would Biohm want to manufacture here? I was about to find out. The name, the Onion Collective, represents the many layers of backgrounds and skill sets they bring to this social enterprise, and their goal is the regeneration of their town. Was it a hard sell? Hey guys, we're going to have a factory making, mycelium insulation panels.
I wouldn't say a hard sell. It was, everyone's like, wow, what? It was like a confused sell. But no, once you explain that mushrooms eat waste and that you can make things from the roots of mushrooms, then everyone's like, oh yeah, wow, that's the future.
They completed a feasibility study looking at the local assets, skill sets, and global industry trajectories. Bio-based material development was a winner, and Watchet had 200 years of experience of manufacturing paper, although these days the old mill looks more like mournful modern art. How long ago did it shut down? How many people lost their jobs?
It closed at the end of 2015, Christmas Eve.
Oh.
Yeah, and it was 175 jobs, so absolutely massive. 20% of the town's workforce lost their jobs overnight. Wow. So yeah, devastating.
That was then. Now EHAB and the Biohm team are paying a visit. They're aiming to be manufacturing by the end of the year.
And through here is where the facility's being built.
Whoa, a little bit of work to do.
Yeah. We have had a lot of delays because of COVID, of course. But through here is where you got the labs, the incubation rooms, where the mycelium insulation panels are going to be grown. And from this entire space, we can grow 3,000 square meters of insulation per month, wow, which is around 20 homes worth of insulation. So over the next 2 years, we're going to be growing 6-fold in terms of the production capacity and have space to grow about 3 times as big as we are at the moment.
Instead of following the typical make, use, dispose industry model, all Biohm's resources and products will be circular.
So all the energy used in the production of our materials will be from renewable sources, if not generated on site. And our materials are actually carbon negative, so they consume more carbon than they release during the production process. For example, 1 square meter of mycelium insulation produced can sequester 0.8 to 1.7 kilograms of carbon, which may not seem very significant, but at a scale of 20 homes worth of insulation per month from our first facility, we're looking at sequestering almost 6 tons of carbon every month. And that's the same as the work of 3,200 trees.
And because no chemicals or additives are used, old panels become the feed for new panels, with customers bound by contract to return materials at end of life. Another unusual aspect of this business is it's a 50-50 profit share between Biohm and the Onion Collective.
I mean, I tell this story about what we're doing quite a lot. I'm always standing up on a stage or talking to a room full of people. And there's always this brilliant moment when you start talking about it and then you're like, okay, so then the mushrooms, they kind of eat the rubbish and then that turns into a new product. And then wait for it, hang on a minute. There's also this thing where plastic, maybe we can like use mushrooms to eat plastic. And you just see people's faces like what? Sorry, what? Like, that's not true.
Oh, but it is. While scientists and mycologists or fungi experts are in the know about the organism's ability to eat plastic, it's big news to most of us. Biohm has received funding for this research from a major UK supermarket chain, and even companies within the petrochemical industry have been in touch, interested in what mycelium could do. Lead biotechnology engineer Samantha Jenkins is running the experiments.
So these are a few of our different strains that we're working with.
Normally, plastic can take anywhere from 10 to 1,000 years to break down, but in this lab, one mycelium strain consumed a piece in 2 months. Samantha is testing the effectiveness of different strains on different plastic.
Yeah, so microbiological genomes are much more flexible than our own. So if, for example, you present them with an issue like there's nothing to eat but plastic, which is our experimental setup that we're using, then they can adapt and evolve much quicker than, for example, we could as, higher organisms. So they're much more flexible with the enzymes that they can produce, how they produce them, and what functions they can use them for.
So they're basically doing us a huge favour here. We've created this mess and they're helping us to clean it up.
Exactly, yeah.
Biohm's using what's called directed evolution in their experiments.
So, for example, the characteristic we want to see is plastic degradation or faster plastic degradation. So we're taking away any other food source, and that's the stress that we're putting on them, is removing any food source that's easier to eat. So glucose or lignin or cellulose, which is what they would normally eat.
So you're looking at loads of different strains to see which is the best performer?
Well, we started with about 15 strains, and now we're down to about 4. So we're narrowing it down to the cream of the crop.
Samantha is also testing mycelium's ability to decompose plastic in water, but it will be at least 2 years before all this technology becomes available. One day, their mycelium panels may even be grown from toxic byproducts, such as plastic and oil, and be harmlessly absorbed into the material. And there are already plans to build another facility in England and a third in the Netherlands.
We've been invited by governments and local authorities and social enterprises from around the globe, Australia, India, all over Europe, to set up our biomanufacturing facilities in their localities.
Eventually, EHAB wants to open source all their technologies, which will hopefully rebuild the construction industry. But that's the big picture. Right now, Watch It locals just want to get their hands on their panels.
I keep having to give out my phone number to people in Watch It now, because increasingly everyone knows about it and everyone's like, right, when's it ready, when's it ready? And we're like, okay, we're nearly there. So yeah, it's exciting. And it will be interesting how we deal with that combination of this kind of big global demand, and we know that there's lots of interest from big firms who are kitting out huge numbers of houses. But then there's also, the local guys here and the small builders, and everyone wants to be, part of that story. So that is quite life-affirming.
It's a really, really exciting way of showing how, industry is not separate to community, government and academia. We need to integrate all those different parts to really have a step change, especially at a time of climate crisis.